Starting with a positive integer m, Alicia creates a sequence by applying the following algorithm. Writes down the number. If it's even, it becomes m over 2. If it's odd, it becomes m plus 1. Writes down the number m plus n plus 1 and repeats the steps. If she starts with 3, what is the fifth term? Okay, so let's go through these steps. 1, 2, 3, 4. And we got to do this 5 times. So the first step, m is 3, right? Okay, so that's the first term, I guess, right there. Now, is m even or odd? It's obviously odd. So if it's odd, we've got to write n is equal to m plus 1. So n is equal to 3 plus 1, which is 4. And then we have to write down step 3 is m plus n plus 1, which in this case would be 3 plus 4 plus 1, which is 8. And then now step 4, which is m equal to that, which is 8. And this 8 comes up here. So this is now the second term. This was the first term. This is the second term. And we're just going to go through this process again. So it's even, so I have to put m over 2. Then I have to put m plus n plus 1, which in case would be 13. And then this, now m equals 13. Okay, now we're on the third term. 13 is odd. So if it's odd, it becomes m plus 1, which is 14. And then we have to add those two and add 1. So that's going to be 28, and therefore now m is 28. So 28 is the fourth term. Now we go through the process again. It's even, so we have to put m divided by 2, which is 14. Then we have to put this m plus n plus 1, which would be 28 plus 14 plus 1, which is 43. And therefore m is 43. And that becomes the fifth term, and that's what they wanted. They wanted the fifth term, and the fifth term is 43. And starting, I guess, in 2023, there's no answer choices for questions 21 through 25. So questions 21 through 25, they no longer have that A, B, C, D. They just want you to write the answer. So in this case, the answer is 43, and that's what you would enter on the exam paper. All the answers for questions 21 to 25 will be 2-digit numbers between 00 and 99, I believe. Now, if it's a 1-digit number, like for example, if the answer was 8, you would write 08 on the exam paper. The integers 1, 2, 4, 5, 6, 9, 10, 11, 13 are to be placed in the circles and squares below with one number in each shape. Each integer must be used exactly once, and the integer in each circle must be equal to the sum of the integers in the two neighboring squares. If the integer x is placed in the leftmost square and the integer y is placed in the rightmost square, what is the largest possible value of x plus y? Okay, so let's first draw in these guys. And let's work with this. Let's play with this. Now, the key in this question is we want the largest, because I'm sure there's many ways of putting these numbers in these shapes, but we want the largest. Okay, so let's concentrate on the largest numbers then. The largest number is 13, so let me first try to fit in that 13 somewhere. Well, the circle has to add up to the other two guys, so if I put a 13 there, 11 plus 2, yeah, and then I want the largest on the ends, so I put the 11 here and the 2 here. So I'm taking care of the 13, and that takes care of the 2, and that takes care of the 11. Now what's the largest remaining number is 10, so that's what I'm going to deal with over in this side. And then how do I get 10 as a sum of two numbers? 9 plus 1 would do it. And since I want the largest at the ends, I put the 9 there and the 1 there. Now let's see if I can make this whole thing work with the remaining numbers, which are 4, 5, and 6. If I put a 6 here, that would mean the 4 would have to go there, because 2 plus 4 is 6. And then the 5 would have to go there, and then 4 plus 1 is 5. So there you go. It all works out. And this is the way to do it to get the largest possible value of x plus y. That's x, that's y. And x plus y is therefore 11 plus 9, which is 20. And on your answer paper, you would put 20. Diwa writes down a list of 4 integers. He calculates the average of each group of 3 of the 4 integers. These averages are 32, 39, 40, and 44. What is the largest of the 4 integers? Okay, so let's say those integers are a, b, c, and d. And therefore, the averages would be a plus b plus c over 3. We'll set that to be 32. Then a plus b plus d over 3. I'll set that to be 39. And then b plus c plus d over 3. 40. And then finally the last one, which would be a plus c plus d over 3, which would be 44. Okay. Now, if we were to make these into equations, we'd have a plus b plus c is 96. A plus b plus d is 117. B plus c plus d is 120. And a plus c plus d is 132. Okay, so if we add up all these guys, we get 3a plus 3b plus 3c plus 3d is going to be 465. And then divide through by 3, we get a plus b plus c plus d is 155. Now at this point, we can get the largest. I believe the largest, according to my letters, is going to be d, because it's got to be the one that has the largest difference between the total and the other 3. So that's this guy, since that's the smallest number. So using that, if a plus b plus c is 96, then that becomes 96 plus d is 155, and therefore d would be 59. And that would be what you would write on the exam paper. Cube A, B, C, D, E, F, G has edge length 100. Point P is on AB, point Q is on AD, and point R is on AF, as shown. So that AP is x, AQ is x plus 1, and AR is x plus 1 over 2x for some integer x. For how many integers x is the volume of the triangular-based pyramid APQR between 0.04% and 0.08% of the volume of the cube? All right, so we have to figure out, first of all, what is the volume of the triangular-based pyramid, and then compare it to the volume of the cube. Now, the volume of the cube, that's easy. That's just length times width times height. And in the cube, they're all the same. It's 100 times 100 times 100. So it's 100 to the power of 3. Now, the area of the triangular-based pyramid, that they have helped you out by telling you that it's 1/3 the area of the base times its height. So that would be 1/3 times the area of the base times the height. Now the base is a triangle, so its area would be 1/2 base times height, where the heights would be AP and the base would be AQ. Yeah. And then this guy in here is the height of the pyramid, which is AR. So let's plug in all our values. This is 1/3, this is 1/2. AP is x, AQ is x plus 1, and AR is x plus 1 over 2x. Okay, let's simplify this a little bit. I believe this is going to be 1 over 12, and then the x is canceled, this x and that x cancel, so then we have x plus 1 squared. And I think that's it. Okay. So now they want you to have a scenario where you have this ratio. So the volume of the pyramid, which is x plus 1 squared over 12, over the volume of the cube, which is 100 to the power of 3, that to be between 0.08% and 0.04%. And that equation is what we have to work with to figure out the values of x. Okay. Now, first of all, these are in percentages. So for example, if it was 1%, you have to convert that to a number. 1% is 0.01. You divide 1 by 100 to get 1.01. So similarly, these percentages, have to be divided by 100 to get an actual number. And when you do, you get 0.0004. And then on the other end, you get 0.0008. So that's very important. And then this guy in the middle, x plus 1, let's just leave it like that, all over 12, all over 100 to the power of 3. Got it? Okay, so now let's multiply through everything by 100 to the power of 3. And when you do, on this side, you'll get 400. The 100 to the power of 3 here disappears because we multiplied through by it. And on this side, you get 800, I believe. Now let's multiply through by 12 to get rid of that 12. And when you do, this becomes 4,800. And this becomes 9,600. And then the x plus 1 is all that's remained. And then now let's take the square root of everything so that this just becomes x plus 1. And then that would be approximately 69.2. You're allowed to use calculators on the Canadian math contests. And this becomes 97.9. Now subtract 1 from everything, so this just becomes x. And this becomes 68.2. And this becomes 96.9. Now they're saying, what are the integers between those two values? Well, there'll be 69. X would equal 69, 70, all the way till you get to 96. And how many numbers do we have there? Well, it would be 96 minus 68. That's how you calculate it, and that's 28. And 28 is what you would enter on your scorecard. Consider positive integers a, b, c, d, and e in that inequality. There are n lists, A, B, C, D, and E, with a mean of 2023 and a median of 2023, in which the integer 2023 appears more than once, in which no other integer appears more than once. What is the sum of the digits of n? Well, they're saying that the integer 2023 appears more than once. So more than once could mean 5 times, 4 times, 3 times, or twice, right? More than once. So let's go through these case by case. Let's say 2023 appears 5 times. Well, that means the list is 2023, 2023, and so on 5 times. So how many such lists are there? Well, there's only one such list, which I just wrote, so I'll just put 1 here. So we'll keep a tally here. Okay, so that's pretty straightforward. Now let's say if there's 4, this 2023 appears 4 times, then we have a scenario where you have 2023, but then you got one other number that we don't know what it is yet. So I'll just represent that as x. Now, the mean has to be 2023 and the median. Now the median, the way I wrote it, okay, the middle value, that's fine. It satisfies 2023 as the median. But the mean, you'd have to add these guys. So 4 times 2023 plus x divided by 5, and that's going to be 2023. And when you solve for this, you get x equal to 2023. Well, if x is equal to 2023, this guy, then we have 2023 appearing 5 times. So that's the same thing as over here. So this gives you nothing additional. You can't have just 4 times 2023 appearing with an additional different number, because it fails the condition that the mean has to be 2023. Okay, no problem. Now we move right along to 3 times. Now 3 times is a little bit different, because there's 3 scenarios in how that can be done. The first scenario is if the 2 numbers, let's say they're A and B, that they're smallest. So you have this kind of scenario, like that. Now, if that's the case, the mean is going to be less than 2023, right? Because these guys, the way I've written them, they're less than, they're the 2 smallest. So if the mean is, if you add up these 5 and then divide by 5, it's going to be less than 2023, and therefore that would not match the criteria that the mean has to be exactly 2023. Now we go to the other scenario, which is you have two numbers that are different, but they're greater than the 2023. So they're like this. Well, in this case, the mean would be greater than 2023 and would fail to meet the criteria that the mean has to be exactly equal to 2023. So the only way we can make this work is if we have one number that's on that side and then one number that's on the other side, like that. And then the mean and the median could possibly be 2023. You got it? Now the only way that the mean could be 2023 is if A and E is equal to 2 times 2023. And all I really did there was just add up the numbers, divide by 5, and let them equal to the mean, and then just isolate it for A plus E. And if that's the case, then let's see here. A plus E would therefore be 4046. And then, for example, if A is 1, E would be 4045, right? And then if A is 2, E would be 4044, and so on down, dot, 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 all the way till you get to 2022 for A and 2024. Now, you can't go further because, remember, A is less than E. And if you look at those, there's 2022 such scenarios. So this case gave me a lot, 2022. So I've made a lot of possible ways of creating this list when 2023 appears 3 times. Okay, so now we're down to our final one, which is when 2023 appears twice. And only twice. Okay, so let's see what we get here. All right, this is going to be the biggest one in terms of mathematics. Okay, so now we want the 2023 to appear 2 times. Okay, if it appears 2 times, then we have to figure out how do we do this. You have 2023, 2023 like this. If we put them all as the other 3 numbers, if you put them all less than, then the mean would not be equal to 2023. And we talked a little bit about that in the previous question. And similarly, if you put the other 3 numbers greater than 2023, the mean could not be equal to 2023. So we've got to put a few on this side and a few on that side. So that's one way of doing it. Or the other way is putting one number as less than 2023 and the other 2 greater than. So those are our 2 options, 2 ways, I guess. Okay, so let's talk about the first one. If you do it that way, then that means that A plus B plus 2 times 2023, which is 4046, plus E is going to be equal to 5 times 2023, right? That's just a mean calculation. That's all that is. So that means that A plus B plus E is 6069. Okay? So that means E is equal to 6069 minus A minus B. Okay. So now we got to figure out, well, how many different ways are there of doing this? And a lot, actually. So let's go through this one by one. If A is 1, then that means B, since B is greater than, it's got to be greater than or equal to 2, but it's got to be less than or equal to 2022, right? Because that inequality has to hold true. Now, how many ways of doing this? Well, B can be anything from 2 until 2022, so that gives me 2021 different ways of doing that. And whatever we choose for B, we would plug into this guy to get a value to get one single value for E. Okay, let's keep going here. If A is 2, B would be between 3 and 2022. And then how many ways of selecting B? This time it looks like 20, I believe. Yeah. And then you just keep going like this, dot, dot, dot. And you'll see that eventually, I think the highest you can go is A equals 2021. And B would be between 2022 and 2022. So I guess there's only one possible value for B, like that. So this is going dot, dot, dot. Now, to add all these guys up, you guys remember that mathematical formula, right? 1 plus 2 plus dot, 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 all the way till n is n times n plus 1 over 2. So if you add up 1 plus 2 all the way till 2021, it would be 1 plus 2 plus dot, 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 all the way up till 2021. It would be 2021 times 2022 all over 2. And that is really just 2021 times 1011. Yeah. Okay. So that is the big number. So of how many cases they have for this scenario. Okay. So we got to do the same thing over here. It'd be very similar. And let's go and do that. So if we use the mean calculation, A plus D plus E is going to be equal to 3 times 2023, so 6069. Very similar to over here. Yeah. So let's see here. Yeah. So for example, now we got to go through this case by case. So for example, D is got to be greater than 2023. So if it is, we can start with 2024, let's say. So plugging that into here, we would get A plus E equal to 4045, right? And my A is anywhere between 1 and 2022 because it's got to hold that inequality true. And the E, therefore, is going to be greater than or equal to the D, which was 2024, so this has got to be 2025. Got it? Okay, so let's go through this. If A, for example, was 2022, then my E, A plus E is 4045, right? So my E was going to be 2025, like that. If A is this should be a 20. Yeah, because E has to be at least 2025. So I think that's the maximum value of A I can get. So I can only go down from there. Yeah, 2022 won't work. It's got to be 2020. Yeah, because if it's 2022, then E would be 2023, and that's not valid because E has to be greater than 2025. Okay, I got it. Okay, so if I keep going down, this will be 2019, and this will be 2026, and then keep on going all the way down to 1. This is going to be 4044. So as you can see, this will give me a total of 2020. And that was for D equals 2024. And then very similarly, you got to go through this again. But this time, for D equals the next one, which would be 2025. Let's make a A and E list again. Again, A, in this case, same thing, I think. It's between 1 and 2022. And then same thing that E has to be this time greater than or equal to 2026 in order to make this inequality up here true. So if I make my A and E list, if E is the highest it can be, it'll be 2026. And then using this formula up here, A would be 20. 2018. Actually, no, we're going to use this formula up here, the original one. And remember, D is 2025. So if that's the case, then A plus E is going to be equal to 4044. Yeah. So this is the formula we're using. It's just slightly modified because of the value of D. Okay. So now we just keep going. If E is 2027, then this would be 2017, and then so on down, all the way down to the point where you go to 1, and this would be 4043. So how many cases do we have here? 2018. And similarly, as you keep increasing the value of D, you'll keep decreasing the total number by 2. So this was 2020, this was 2018. And if you made D, for example, equal to 2026, and you went through that big long song and dance, you would get a total of 2016, like that, cases. And then eventually, this would come down to just 2 cases for the last D, which is D equal to, for a value of D of, I believe, 3033. Now, just to go through this, if you're wondering how did I get that 2, I don't mind going through it one more time. First, you got to look at that. A plus D plus E has to be 6069, right? So the A plus D plus E has to be 6069. Now, if you have set this D to be 3033, that means A plus E will be 3036. Okay, so make my little A and E again. Remember, we have to abide by this inequality here, right up here, that E has to be greater than D. So if E is greater than D, then we start at 3034. And if that's the case, then if we look at that equation, then A would be 2. And then if we keep going, 3035, A would be 1, and then that's it. After that, we won't get any more values. So that's how I got this 2. So we got to add up all these guys. The 2020 up here, the 2018, 2016, all the way down to 2. So it's basically like a 2 plus ... plus 2016 plus 2018 plus 2020, I believe, is the last one, right? Okay, so this is similar. Now, how you would add this up is you'd factor out a 2, and if you do that, this is always going up by 1s, right? Sorry, always going up by 2s, like 2, 4, 6, 8. So when we factor out the 2, it becomes 1 plus 2 plus 3, ... all the way up to, this would be 1008, I believe, and then 1009, and then 1010, like that. And then we can use our handy dandy formula there. It'd be 2, and in the brackets it'd be 10 10 times 10 11 all over 2, and then the 2's canceled, so you just get 10 10 times 10 11. There you go. Now we have to add them all up. So let's go back and let's see what we had. Okay, so we had this 1, this 2022, and then we had this guy, and then finally we calculated this guy over here. So let's put that together. So we had 1 plus we had 2022 plus we had this 2021 times 1011 plus this guy over here, which is 1010 times 1011. And what does that all represent? Just in case you've forgotten, it represents the number of lists, which is represented by n. So that's n, basically. This is n. N equals. And when you do this math, I'll let you crunch out all the numbers. It's 3,066,364. And what they're asking for is the sum of the digits of n. Well, the sum of the digits are 3 plus 6 plus 6 plus 3 plus 6 plus 4. And that is 28. And 28 is what you would write on your scorecard.